Okay, so what do we need to do now? Well, we need to make sure that we have one of these two basic indeterminate forms, 0 over 0 or infinity over infinity, before we apply L'Hopital's rule to the limit. So we're going to plug in infinity again. We know that 1 plus 1 over x cubed is going to go to 1, and the natural log of 1 is 0, which gives us 0 in the numerator. In the denominator, we have the reciprocal of x squared, which is 1 over x squared, which also goes to 0, which basically means we have 0 over 0, which is one of the two basic indeterminate forms. So at this step, we can now apply L'Hopital's rule. But you must mark that you've used L'Hopital's rule, otherwise it is completely wrong. So how do you show that? You are required. It is not optional. It's not just advised. It is mandatory. Put L'H above the equals. What you're claiming is that the limit of this will be equivalent to the limit of the next thing we write. But they are not true except under L'Hopital's rule. So what is L'Hopital's rule? Well, L'Hopital's rule says if I take the derivative of the numerator and the derivative of the denominator in the quotient, I'll get the same limit. Now this is not the derivative of a quotient, because the derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I'm not doing that. L'Hopital says ignore the bottom, take the derivative of the numerator, in this case natural log. Then ignore the top and take the derivative of the bottom, in this case 1 over x squared. Then divide those two derivatives and take the limit of those two in the fraction, and you'll get the same number that you would have gotten from the original limit. That's L'Hopital's rule. But they're not equal except under L'Hopital's rule. So it's not optional. I can't emphasize that enough. So we still have E. We still have the limit as x goes to infinity. And now I need to take the derivative of the numerator. Well, this is chain rule. So the derivative of natural log is 1 over u, or 1 over the inside, 1 over 1 plus x cubed times the derivative, 1 over 1 plus, what did I do? 1 over 1 plus 1 over x cubed. I've got too many 1 overs. Okay, now the next thing we need to do is take the derivative of the inside. Well, the inside is this 1 plus 1 over x cubed. The derivative of 1 is 0. I can write 1 over x cubed as x to the negative 3. And so this becomes times negative 3x to the negative 2. This right here is the derivative of the inside of the natural log function. Then I need to divide that by the derivative of the denominator. Well, remember that 1 over x squared, like 1 over x cubed, can be written with a negative exponent as x to the negative 2. So I'm going to take the derivative of this form of it, since it's easier, and that gives me negative 2x to the negative 3. Now, obviously, that and that are not equal. They're not the same. And they wouldn't be the same, except that we were able to do L'Hopital's rule indicated by L'H. So now I need to do just some arithmetic and algebra to clean up this bottom here. And I'm going to move to a new sheet of paper because it's getting to where I need to write larger so you can see what I've got. So I'm going to rewrite down here. And I do not put L'H again. I only put that on the one step where I actually took the derivative of the numerator and divided by the derivative of the denominator. And then I don't put it again. So I have E, I still have the limit, x is still going to infinity. You'll notice this is great big, all right? You're not going to be able to fit this onto lined notebook paper. Forget the lines. So now I've got this negative 3 in the numerator, and this x to the negative 2 would drop to the denominator of the numerator. So this becomes over x squared times 1 plus 1 over x cubed. Okay, so that's my numerator of this fraction. And then I have negative 2 times x to the negative 3. The negative 2 has its own power, which is 1, so it stays in the numerator of the denominator. And the x to the negative 3 drops down as x cubed. And you'll notice that even as large as I wrote, this enormously complex fraction is creeping down to where the base is. It's a monster. This line is longer than the others because it represents the true division from the original numerator and denominator. So how do I deal with a complex fraction? Well, the bottom of the bottom is actually the top. So you divide by multiplying by the reciprocal. So basically, I could rewrite this as negative 3 over, well, I could distribute the x squared across here, or I can just leave it separated. It's kind of up to you. I'm going to leave it for right now until I see what all I've got. Times, and take the reciprocal of the denominator and multiply, so I get x cubed divided by negative 2. Well, the negatives cancel, and the 3 divided by 2, that's a constant. It doesn't depend on x, which is what the limit depends on, so it will pull out of the limit. So I end up with e 3 over 2 limit x still going to infinity. I've got x cubed on top and x squared on bottom, which gives me 1x in the numerator, divided by 1 plus 1 over x cubed. Now, I'm looking at this and I'm wondering, well, what do I do now? Well, when in doubt, plug in again. Okay, so I've got x going to infinity, so I'm going to plug it in. I've got x cubed in the denominator, so x cubed is going to go to infinity, but 1 over that goes to 0, which means my denominator here is basically going to 1, because this part goes to 0, the denominator goes to 1. So this denominator goes to 1, but this is x, and x is going to infinity. Well, infinity over 1 is infinity. And then I've got 3 halves times infinity, which is still infinity. So what is that going to do for us? Okay, I'm staring at this and I'm wondering what's gone wrong, because I know this shouldn't come out to be infinity. So I'm going to have to go back and check. I could re-record the video, but if you never see me troubleshoot a problem, how will you know how to troubleshoot it? The problem is I got left with this x in the numerator, which tells me that somewhere some power on x is wrong. So I'm going to go back up to this step and start checking for it. So first thing I'm going to check is the derivative of this. So it's 1 over u, 1 plus 1 over x cubed, times the derivative of the inside. And I think this is where I went wrong. So I can write 1 over x cubed as x to the negative 3. So the derivative should be negative 3x to the negative 4, not negative 2. So this should be a 4 right there at that step. What about this one? This was 1 over x squared, which is x to the negative 2. The derivative is correct. Negative 2x to the negative 3. Next step down here. Let's see, this negative 3x to the negative 4, this 2 should be a 4. So that's now a 4. This is still okay. Coming over here, this x squared should be a 4. And now I've got x cubed over x to the 4th, so where does my x actually end up? Not in the numerator, but in the denominator, which is much better for me. Let me rewrite it correctly. E to the 3 halves, limit, x going to infinity, 1 divided by, this should be x times 1 plus 1 over x cubed. Okay, well, This goes to infinity. 1 over infinity goes to 0. So 1 plus 0 goes to 1. So this whole part here goes to 1, but this is x. And x goes to infinity. So I get 1 divided by infinity, which is 0. I can take the limit of this, which is 0, and so I end up with e to the 3/2 times 0. Well, 3/2 times 0 is 0. And what is e to the 0th power? 1. I know, it's shocking. All this work on 2 pages to get 1? Yeah, all that work to get 1.